All right. So you said you were a pilot for 50 years, right?
Yep.
Okay. How often do you have to adjust for the curvature of the Earth?
You don't have to adjust. You're flying at a constant altitude above the Earth.
Yep. And what about Earth rotation? If you're landing on a north to south runway, do you have to adjust for Earth rotation?
No, because the atmosphere is travelling at the same approximate speed of the Earth.
Great. So
you're flying, the aeroplane is travelling relative to the air mass that it's in. What the ground's doing is irrelevant until you land.
But the ground, according to you, is moving, sir. Are you aware of how fast your Earth is supposedly spinning at the equator in 1 second?
Well, it would be 1 degree per second. I'm not sure what that is in miles.
Nope. It's 460 meters a second at the equator.
Right.
So if you land your plane on a north to south runway at the equator, are you going to be chasing the runway sideways 460 meters every second?
No, because you're flying in an atmosphere of air that's travelling at the same speed.
Yeah, but
so
if you
the speed becomes irrelevant.
But if you claim the atmosphere just moves with the Earth, it's the same as me saying the Earth is stationary.
It would be exactly the same.
Exactly. You agree with me that you can't prove using your plane that the Earth is moving, right?
No, I never said I could.
Great. So you're a flat earther then?
No.
Oh. Wait, hang on. So you don't adjust for Earth rotation, you can't tell the Earth is moving from your plane. You never have to adjust for Coriolis.
If the wind mass, the air mass is moving at the same speed as the Earth, then it's completely irrelevant.
Great, but I just said it's the same thing as the Earth being stationary. So if the Earth
it's the same result, yeah, it's not proof of either.
Great, exactly. So like, what about Earth curve? You said you don't adjust for Earth curve either. So let me ask you this. You have an instrument in your plane called the attitude indicator, correct?
Yep.
Okay, and that has a gyroscope connected to it that maintains rigidity in space, correct?
Yep.
Great. So if you fly straight and level over the Earth, and you never have to change your orientation in relation to the ground, you're flying over a flat Earth, sir.
Nope, absolutely not.
Okay, what makes you
You're flying at a constant altitude above mean sea level.
Correct. And if that mean sea level is flat and it's the same level all around the Earth, let's just say the Earth is flat, it's the same thing, isn't it? If the Earth is flat and you're flying east to west in a circle, it's the same exact thing. Welcome to Flat Earth.
It doesn't prove that it's flat.
Yes, it does.
Doesn't prove anything.
Check this out. See this image I've got on screen? You see see this plane here? Okay.
Oh yeah, the 6,000 mile long aeroplane. Yep.
Yeah, I'm just showing. It's big so that you can see it, sir. Right. So if we shrink it down, it's still here, right? But you won't be able to see it.
Yep.
Okay. We're going to fly to the equator. In relation to where the plane was here, it's nose down, right? To fly around this curved line, is this line curved? If you maintain the altitude around a globe, is this line curved?
Yeah.
But you said you don't need to dip the nose down to account for curvature.
You're talking about dipping the nose 1/1000th of 1 degree constantly.
A plane flying 500 miles per hour would have to account for just under a mile of curvature every minute.
No, it wouldn't.
Yes, it would.
Your math is wrong.
No, it's not. It's actually completely correct. How big is the Earth, sir? At the equator?
I have no idea. Nope.
You have no idea, but you just told me I'm wrong. You don't know how big the Earth is, so you don't know how much it curves. But you just told me I'm wrong.
Doesn't it curve something like 8 inches per mile squared?
Exactly. So if we apply that now to how much you fly in miles per hour, that's just under...
At 500 miles an hour, at 600 miles an hour, you're doing a mile a minute. So you have to drop 8 inches a minute.
No, you'd have to drop.
Nothing.
No. You'd have to drop over about a mile a minute, sir. If you're flying over 600 miles per hour, that's roughly a mile a minute. You'd have to drop.
That's what I just said. It's a mile a minute, and the Earth drops 8 inches per mile, so you're dropping 8 inches per minute.
No, that's already with the calculation done, sir. You're dropping a mile of curvature per minute, not 8 inches. A mile of curve per minute. You just told me the plane never dips its nose, right? You never have to adjust.
I said it dips its nose minutely, not enough to even measure.
But
the Earth drops. You just agreed that the Earth drops 8 inches per mile.
No, I agreed that your model claims that. I'm saying that if you're flying straight and level to your destination, you never dip the nose ever.
I'm flying at a constant altitude above Earth.
Correct. So if the Earth is flat, it's the same thing, huh?
It doesn't prove that the Earth is flat.
Yes, it does.
Also, your attitude indicator maintains rigidity in space. So if you were dipping the nose down, you'd see the gimbal base change its orientation relative to the gyroscope, but it doesn't do that.
Yeah, like when you're 90 degrees, so you're here and you go here, does your attitude indicator now, is it out by 90 degrees now?
There isn't a plane on Earth that could travel that far.
Yes, there is. Are you joking?
But yeah, I've flown to South Korea to talk about flat Earth and took 14 hours, and we flew around the globe, if it was a globe. But the airplane flew the FAA trains pilots to assume a flat, non-rotating Earth because the Earth is flat and non-rotating. Your profile picture actually proves the Earth is flat.
I told him that before too, yeah.
My profile picture isn't an artist's drawing. It's nothing to do with proof of anything.
It proves that the sun sets above the horizon.
Okay, listen, I'm already sick of this discussion. I've been to 72,000 feet. I've seen it with my own eyes. I'm really not interested in what you think.
This is 120,000 feet, so this is no curve. It's just higher than what you're claiming.
What's 120,000 feet?
This image that you're seeing on screen, sir?
You're 7,000 mile.
This is 120,000 feet on screen right now, sir. You didn't see curvature from your height that you just said.
So my question to you, Claude, is if you're flying from the left side of this red line to the right side of this red line, are you flying around a curve? That's what
Probably, yes. I don't know how wide that line is.
That was the longest silence. That was the longest silence I've ever heard on a flat Earth debate. Thank you. I appreciate that, Claude. We'll clip that.
Yeah. So hang on real quick.
Clip whatever you like. I'm trying to figure out how wide the angle is on your picture, and it doesn't look very wide.
Okay, but it's from 120,000 feet. Is there a curve? Do you see curve on the screen?
I can't see enough of it to tell.
Let me ask you this, though. If you go to the beach and you see a boat go away from you, does the boat go over the curve?
Yeah.
Okay. Well, how come there's no curve at 120,000 feet? How's the boat going over the curve at 3 miles away? Can you see 3 miles of horizon here and it's obviously flat? Obviously,
I don't know what that photo is. I don't know if it's computer generated. I don't know who's fucked with it.
It's a high altitude. Hang on real quick. It's a high altitude balloon footage.
Yeah, were you in the balloon?
Yeah, but just to help you out here, Twat, Neil deGrasse Tyson. Neil deGrasse Tyson admits he's a PhD astrophysicist. He says you can't see the curve from 120,000 feet. He says it's flat.
Yeah, that's been debunked. So
no, it doesn't.
Let's try again.
On screen.